inverse functions and relations. So just like inverse operations that are operations that undo each other, inverse functions are functions that completely undo the operations of each other, so that your input never changes. If you do a composition like we practiced yesterday, your in and then out is going to link right back to the same input, and graphically it talks about how there are reflections across y equals x. We'll see that in a minute. So we're going to look at two things. One is how to generate the inverse algebraically, and then how to use compositions to figure out if two functions are in fact inverses of each other. Okay. So first things first, we're going to find the inverse of f of x. So really all we're going to do is we're going to rewrite, we're going to change that to y. Y equals 2/5 x minus 1/5. And then we're going to swap out x and y, because if we're undoing the operations, then it doesn't matter which one is where. X equals 2/5 y minus 1/5. And then we solve for y. So I'm trying to get the y by itself. We're going to add 1/5. And I've got x plus 1/5 equals 2/5 y. And then the easiest way is to multiply by the reciprocal. So when we distribute, we get 5/2 x plus 5/10, right? 5 times 1 is 5. 2 times 5 is 10, which is 1/2, equals y. Now I can rewrite that f negative 1, because that's our notation for inverse, right? I mentioned it again up here. Inverse functions of x equals 5/2 x plus 1/2. So we're going to graph both of these in our coordinate plane together. Now those aren't friendly points. I could plot a point at a half and then run my slope from there, but it's not the most reliable way to go about it. So if I just put this in my calculator, I'm going to go to the table. So I've already got my original one there, but I turned it off just so that I'm not confused by numbers. And we're going to 5/2 x, which if I think about my slope, my rise and my run are definitely switched. I just need to know if this adding a half is enough to make it completely true. So we go to the table, find some plottable points. Change that. And so there's -1, -2. 1, 3. 3/8 way up there. 3/7. Those are the only ones that are going to fit neatly. So we're going to straight edge and draw through. And we want to make sure we label that as the inverse. And then my original function, 2/5 x minus 1/5. So if I go back, I'm going to arrow over the equal and hit enter to turn this one on and get rid of that one. Go back to my table. -2, -1. 3, 1. Notice how those numbers switched. That's a good indication. My x became y and y became x. Label that one as f, the original function. And then we're going to go back through and we're going to plot y equals x. So remember that's 1, 1, 2, 2, 3, 3. So it goes through 0, 0, 1, 1, 2, 2, 3, 3, -1, -2, -3. And I'm just going to leave this one as dotted because it's not one of our original functions. We're just using that as a tool. And I can see how these are equidistant from there in all places. So I know that this inverse is correct that we got algebraically. Okay. So the way we check if two are, then we plug them in and find out. Okay. Are these inverse functions? Well, f of x, g of x. For them to be inverse functions, both directions have to be true. F of g of x, I'm hoping that it just equals x. And g of f of x, I'm hoping that it equals x. So it's if and only if both of them are true. So we're going to set up and do some substitution and see if it works. So f of g of x. So 2 minus 7. I left where the x goes, and we're going to put all of this in there. 1/2 times x plus 7. Okay. And when I distribute, 2 times 1/2 is 1. X plus 7 minus 7. X plus 7 minus 7. 7 minus 7 goes away. This just equals x. So we're halfway to knowing it's an inverse. But we have to check the other direction. So we're going to take g, 1/2 of x plus 7, close it. And we're going to substitute 2x minus 7 in there. So that when we work it, 2x plus 7, we're going to simplify in here first because we're not multiplying any of that. And I can't multiply across this double wall of parentheses. So we're going to leave the 1/2. Nothing is multiplying by that, so I can kind of ignore these. -7 plus 7, those cancel out, and it just says 2x, and then half of 2x is x. We got 2 simplified all the way down to just x. So yes, they are inverse functions. Okay, so let's try the second one. 4x plus a third, 1/4 x minus 3. So again, there's my f, here's my g. So we're going to start with f on the outside, 4 times whatever x is, plus 1/3. And we're going to substitute in 1/4 x minus 3 for where the x used to be. Right? This was my x right here. And then when we work it, 4 times a fourth is 1x minus 12 plus 1/3. This is not going to cancel out, so I know this is not going to equal x. I don't even have to check this side. I have enough information to know that no, these are not inverses.